In this next section, we're going to walk through how the periodic table is organized. Before we dive into how the elements are separated and how they're arranged, feel free to click on this link right here to enjoy Tom Lair's famous Element song. One of the ways that the periodic table can be divided is into metals, nonmetals, and metalloids. In the image that you see, the metals are on the left side of the periodic table in blue, and they take up most of the periodic table. The nonmetals are found in the upper right-hand corner and are shown here in yellow. And there are a few elements that have properties of both metals and nonmetals. And we find them on the border between or separating metals from nonmetals along this stair step that we can draw that you see here in bold. And here in pink, we see those elements. They're called metalloids or sometimes semimetals. There are some general characteristics that help us to identify something as either a metal or a nonmetal. And as I mentioned on the previous slide, metalloids can have properties of both. So metals are often shiny, whereas nonmetals are dull. Metals are good conductors of heat and electricity, whereas nonmetals are not. Metals have a very high density, meaning that their atoms are very tightly packed into a solid oftentimes, where nonmetals are not. They have a much lower density. Most nonmetals, or many nonmetals in their elemental natural state, are gases, in fact. Metals are malleable, which means they can be hammered into a shape, whereas nonmetals are quite brittle and break under pressure. Metals generally are solids. Nonmetals can be solids, liquids, and gases. Metals have high melting and boiling points, whereas nonmetals have low melting and boiling points. Metals are what we call ductile, which means that you can draw them or form them into wires, whereas nonmetals cannot be formed into wires. Metals on the left side of the periodic table tend to lose electrons and become cations, as we talked in the previous section, whereas nonmetals tend to gain electrons and become anions. These types of physical and chemical characteristics are things that we can use to identify elements as either metal or nonmetal. There are a few special groups on the periodic table or columns on the periodic table. Elements that are in the same group tend to have similar characteristics, and some groups have very distinctive properties and are given special names. You can also expect that elements in the same group will react similarly as well. So in group 1, all the way on the left, we have the alkali metals. And a fun Google search might be to watch the reactivity of these alkali metals, lithium, sodium, in water. They're very highly reactive in water. Next to them, also quite reactive, but a little bit less so, are the alkaline earth metals. In the middle of the periodic table, this big block of metals are known as the transition metals. And then all the way to the right side in the non-metal category, we have noble gases. And right next to that, starting with fluorine, these are the halogens in group 17. A few more details on these special groups. Group 1, as I mentioned, are the alkali metals. They are very reactive and quickly lose electrons in those reactions. They will react with the halogens in group 17, like fluorine and chlorine, to make salts. Group 2, the alkaline earth metals, are also reactive, but less so than the alkali metals, and also lose electrons in reactions. In the middle, that big block from groups 3 to 12 are what we call the transition metals. They have fairly low reactivity and are what we think of when we think of our typical metals like copper, silver, gold, iron, things like that. Group 17 to the right side, starting with the element fluorine, are the halogens. They are nonmetals and are also very highly reactive. They gain electrons in reactions and, as mentioned, will react with alkali metals like sodium to form salts. Finally, the very last group, group 18 in the periodic table, are the noble gases. They all are gases. They are non-reactive and are very stable.